Hello everyone, welcome to Tech with Machines. Our today's topic is data skewness. This is one of the most commonly asked interview questions in Spark, and if you are a data engineer, you should really know what data skewness is, how it impacts performance, and how you should fix it. So without any further delay, as I said that it's most common and it actually how you will deal with data skewness, it is being asked in a multiple ways or rephrased in multiple ways, but eventually the most common concept is data skewness in PySpark because that is what can slow down your Spark jobs. So how do you deal with data skewness in a production environment and optimize Spark performance? Because this is the most common problem you will face in your production Spark jobs if you're partitioning or if your data is not evenly distributed. Now, what does data skewness really mean before we jump into how to fix it? It is actually, and you need to understand it because if you want to really be able to answer it in a more effective way in an interview question, you should really know its in-depth understanding before you could answer how to fix it. So what does data skewness really mean? It means an imbalance in the data distribution, which means your data is unevenly distributed among few partitions or tasks, which could lead to slow or straggler jobs. For example, assume you're dealing with transactional data and few categories are actually having more number of transactions comparative to other categories. So this, if you are using category as a partitioning key, so this can cause an imbalance in the data distribution, and there can be few tasks which are dealing with the skewed data. They can slow down or they can have a memory pressure, right? So most important two pointers which actually explain that how it impacts performance is that firstly you have a slow or struggling job. It's a struggler. The job is struggling with the effective resource utilization because there are certain tasks which are actually using more resources, dealing with skewed data and taking longer time to process that data. Second is memory pressure, because if you are dealing with skewed data, you will actually use more memory, which can lead or which can finally output in an out of memory exception. So these are the two common issues which occurred with data skewness. Now, how do you really fix it? The first and foremost thing, because it is related to uneven distribution, so you might want to fix the distribution of the data by making it evenly distributed across the partition. So repartition or increasing the number of partitions which you are dealing with might help to evenly distribute data. Or even one of the common techniques called salting can be used to evenly distribute the data. Or doing a certain kind of a join technique like skewed join technique to handle skewed data separately. Or you can pre-aggregate data using a map combine strategy so that you can avoid lot of shuffling happening over the disk, which can slow down your job, right? So now how do we code it? Let's dig into that. So here we are with a Jupyter notebook, and I have named this notebook as data skewness. I've already created and compiled the code for this particular example. So I'm using a CSV where, as you can see here, I'm reading that CSV. So just before we dive into the CSV, let's first let me give a quick recap of our previous sessions where we were dealing with Spark session. So as a first starting point, you will have to create a Spark session, and for that we will actually load it from pyspark.sql, because there are some functions we are also using from pyspark.sql.function, so I have imported that as well. So first thing we did was creating a Spark session, and in this case I have named my app as dataskew management. After creating the Spark session, what we are dealing with is reading the CSV file where we have created the skewed data, and in this demonstration what we are doing is we are saying that the A key is appearing more frequently than other keys, and that's why the data can be skewed. Now, as a first example which we are using here is using salting. So what we did was that we actually created a salted key. In that case, we are reading the column key and basically suffixing it with a random key generation. So as you can see now, the salted data looks something like this. And when now we use the aggregation on the salted key, it will be pretty faster comparative to the other way of doing aggregation, which would have been basically on the key alone. So that's the first technique of being able to basically create even distribution of the data. Other technique could be that we use map side combine. So in this case, we are basically grouping by key first to handle the skewness and aggregating them. And so basically you pre-aggregate the data to avoid shuffle. So that could be the other example of dealing with the data skewness. So these are the two pretty examples of how you can actually deal with data skewness, and it can help you with the event distribution and optimizing the Spark performance. That's it for today. I hope you liked this video, and if you did, please like and subscribe to the channel. It would help me and it motivates me to create more videos. We'll deal with another problem in another video on the Spark interview. Thank you so much for watching and hope you have a nice day.